Section P6 covers representing data graphically. First, we're going to cover constructing a line plot. Okay, the first set of graphs we're going to talk about are line plots. And with line plots, you're going to get a set of data to organize, and you just mark the X's on your graph. So 93, 70, and so on. And keep with that process. And eventually, you will have your entire line plot with the data, and it's a lot easier to see, that 76 occurred the most without having to look at this big string of numbers. And now for stem and leaf plots. Okay, the stem and leaf plots are a quick way to organize the data. So the stems represent the first digits of the number, and the leaves represent the second digits. So this is a stem and leaf plot for test scores. This is telling us that 2 students had a 64%. And down here, 3 students had an 83%. 1 student had a 96%. And after you get your stem and leaf plot put together, it's a quick and easy to analyze it. We can see that most of the students scored in the 70s and quite a few in the 80s. So this was the most common test score range in this class. You can also make a double stem and leaf plot where it's easy to compare 2 groups. You can see from this data that the second group had higher test scores than what the first group of students did. Now to create our own stem and leaf plot. The table below shows the percent of population of each state that was 65 or older in 1993. And we'll create a stem and leaf plot from this data. Okay, next, to try to create your own stem and leaf plot, first thing you need to do is figure out what your stem should be. So since my numbers range from 4 to 18, that's what we want to put into our stem. So that's our stem part, and now we can start adding in our leaves. So the first one is 4.4. I think that's from Alaska. Yep. And then we don't have any in the 5s or the 6s, and so when it comes down to the rest of them. But then you can just plug in the rest of your data points for just the leaf part, and you will eventually have your whole stem and leaf plot. And now it makes it pretty easy to analyze the data too, to see quickly, well, Alaska was way lower than the rest of the states, and so on. And you can see that this is the most common one to occur. So another easy way to analyze the data. We can make frequency distributions where we have tally marks to total up the data, or we can make histograms, which is similar to a bar graph, but it uses the entire real number line and the bars are connected. Whereas a bar graph, the bars are separated by numbers or. We can create bar graphs, and this graph represents the average monthly precipitation in Houston, Texas. And if you'll notice, the bars are separated along a number line. Now, constructing line graphs. Line graphs are formed by plotting points on a graph and then connecting the dots. And you'll also notice a line graph is similar to a histogram in that it uses the full real number line, not just certain points. I hope you enjoyed exploring data and representing data graphically. Now you can do your example problems in the book.